In this lesson, we're going to go over how to classify ionic reactions. So there are three types of ionic reactions that you should be able to look at and classify. The first one is called a synthesis reaction. In a synthesis reaction, two or more reactants combine to make one product. So what this would look like. I'm just going to do like a general formula without elements to start. Let's say I had A plus B. These are my reactants, and they are going to combine together to make one product, A, B. So A combines with B to make compound AB. Let's see what this would look like with some actual elements. Let's say A was sodium, and sodium combined with chlorine, diatomic chlorine, to make sodium chloride. So you should be able to look at this reaction and identify it as synthesis. Reactant plus reactant yields product. Number two, a single displacement reaction. In a single displacement reaction, a single element reacts with a single compound. So again, we'll start with our general reaction. Let's say I had a single element, A, and it's going to react with an ionic compound. It's going to react with B, C. What's going to happen is A can kick B out of that compound. So now A is bonded to C, and B got kicked out. Let's look at what this would look like with an actual reaction. Let's say I had the element copper, and it was reacting with the ionic compound silver nitrate. So what happens is copper comes in and it is going to kick out silver, and it's going to bond to nitrate. So now the ionic compound is formed between copper, nitrate, and silver got kicked out. So now silver is by itself. So this would be a single displacement, a single element reacting with an ionic compound. The difference between single displacement and synthesis is chlorine is not chlorine is not an ionic compound. An ionic compound needs a cation and an anion. So in single displacement, a single element reacts with an ionic compound. It needs to be made up of a cation, like silver, and an anion, like nitrate. The third type of reaction that you need to identify and classify, is called a double displacement. Double displacement reaction. In double displacement reaction, two ionic compounds react and exchange ions. Let's say I had a compound A, B, and it's going to react with compound C, D. So single displacement differs from double displacement in the number of ionic compounds. Single displacement has one compound. Double displacement has two compounds. What happens in a double displacement reaction is they just exchange ions. So now A is going to bond to D. And C is going to pair up with B. All right, let's look at this with some real ionic compounds. Let's say I had silver nitrate plus sodium chloride. All that happens in a double displacement reaction is the cation from the first reactant bonds to the anion from the second reactant. Cation from the second bonds with anion of the first. So the difference between a single and double displacement reaction has to do with the number of ionic compounds. In a single displacement reaction, I have one ionic compound on the reactant side. In a double displacement reaction, I have two ionic compounds on that reactant side. We're going to do some practice, but we're also going to do some extra balancing practice. Balance and classify the reaction. Mg plus O2 yields MgO. Let's start by classifying this. Is it synthesis? Is it single? Or is it double? This one looks like a synthesis reaction. Remember, in a synthesis reaction, you have two reactants on the left-hand side. They combine to make one product on the right. A plus B yields AB. Synthesis. Now let's balance it. I have two oxygens on the left, only one on the right. Once I add that coefficient of 2, that now gives me two magnesiums, so I can add a 2 over here. Second example, NaCl plus F2 yields NaF plus Cl2. So first, let's try to classify this. It is not synthesis. Synthesis is two reactants, one product. Here I have two reactants, two products. So now let's look at the number of ionic compounds. One ionic compound, single displacement. two ionic compounds, double displacement. Ionic compounds need to be made up of cation and an anion. Cation, anion. NaCl is ionic. Fluorine is not. One ionic compound, so this would be single displacement. Now let's balance. I see two fluorines on the left, but only one on the right, so let me add a 2 here. That now gives me 2 sodiums, so let's go back and get 2 sodiums. That now gives me 2 chlorines, and here I have 2 chlorines, so we're balanced. Next one. Let's do aluminum plus oxygen produces aluminum oxide. Two reactants joining together to make one product. This is another example of synthesis. All right, let's look at these oxygens. On the left-hand side, you have 2. On the right-hand side, you have 3. Whenever you have a reaction like this, make the odd number even. If I add a coefficient here, I'm always going to get an even number. Anything times 2 will always get me to an even number. So let's make this one even by adding a 2. 2 times 3 gives me 6 oxygens. So over here I need 6 oxygens. I can add a coefficient of 3. 3 times 2 is 6. 2 times 2 would be 4 aluminums. So I can add a coefficient of 4 for aluminum. D. Fe2SO4 3 plus KOH yields K2SO4 plus FeOH3. So first, let's start by classifying it. Iron 3, sulfate, ionic compound. Potassium, hydroxide, ionic compound. 2 ionic compounds. So this reaction would be double displacement. Let's balance. On the left-hand side, I have 2 irons. Here I only have 1. Let it lead you. 3 hydroxides times 2 gives me 6 hydroxides. Here I only have 1. 6 hydroxides. That now gives me 6 potassiums. Here I only have 2, so I can add a coefficient of 3. 3 times 2 gives me 6. And then look what happens with our sulfates. 3 sulfates, 3 sulfates. So this one is balanced. Last one. Let's do aluminum plus iron 2 oxide produces aluminum oxide plus iron. Think about how many ionic compounds we have. Aluminum is not an ionic compound, it's just a single element. Iron 2 oxide, cation, anion. This is an ionic compound. I have 1 ionic compound, so single displacement. Now let's work on balancing it. 1 aluminum on the left, 2 aluminums on the right. Iron already looks balanced, but let's look at those oxygens. 3 oxygens on the right, only 1 over here, so I can add a coefficient of 3. 3 oxygens, 3 oxygens. Well, now that changed how many irons I have. So now I have 3 irons on the left. I would need a 3 on the right. Remember, we can either leave these blank, or if you wanted to put a number in there for completion, we can put a 1. Adding that 1 is not going to change the number of ions. 1 times 2 gives me 2 aluminums, and I still have 2 aluminums.